Okay, so we'll have a look now at some, I suppose, slightly more tricky questions where we need to use the formula. So in this question, we're given a binomial distribution. So I've got x is distributed binomially with a number of trials of 5, but I'm not given the probability. What I am told is that the probability of x being equal to 3 and the probability of x being equal to 4 are the same. Okay, so I'm going to do the first one, I'm going to pause and then give you a chance to do the second one. So we had our formula from a previous page, which was given like that. Okay, I've preferred to use the NCR notation for this, but they're exactly the same. N over R is the same as NCR. So, so given what we need to know is that given a variable that is distributed binomially with a number of trials n and a probability of p, then the probability of x being equal to something is this. So NCR multiplied by the probability to the power of R times the probability of it not happening, so 1 minus the probability to the power of n minus R. So that's what we need to know. So let's use that for this question. So I'm given that and I'm given that. So what I want to do is to write out an expression for the probability of x being equal to 3. I'm going to do the same thing for the probability of x being equal to 4, and I'm going to equate them and I'm going to see if I can solve it. So let's just take this a bit at a time. So the probability of x being equal to 3, using my formula here, is 5c3 multiplied by the probability, which I don't know, to the power of r. Don't forget, in this case my n is going to be equal to 5, isn't it? And here my r is 3. So it's the probability of, p to the power of 3 multiplied by 1 minus the probability, which I don't know, to the power of n minus r, which is 5 minus 3, so that is 2. And if you remember from a previous video, those two will always add up to that. Okay, right, I'm going to just evaluate this. I'm going to do my 5c3, and I think when I did it before I recommended using the scientific calculator because you got the NCR down there. I'm just going to do this on the graphical calculator just to show you where to find it. So if I go on to it's just a bit more, there's just a few more buttons to find it. If I go into the normal part of the calculator, I press option and then go across. We get a thing that says probability or prob. Press probability, and there's the NCR. There's a thing called NPR as well, which you can see on the calculator. So that's where I'm going to do my NCR. So I'm going to do 5 NCR 3 and I get 10. Okay, so that is going to be 10 times p cubed times 1 minus p squared, and that's as far as I can go for the moment. So let's do the same thing for the probability of x being equal to 4, and this time got my n is 5, so I've got my NCR, I've got my r is 4 this time, 5c4 times the probability, which I don't know, to the power of r, which is that, multiplied by 1 minus probability, which I don't know, to the power of n minus r. So 5 minus 4 is 1. these two again add up to the 5. Do my 5C4 on the calculator, and I get 5. So I've got 5 times p to the power of 4 multiplied by 1 minus p. Okay, so what I'm told in this question is those two things are equal, so I can equate those. So I've got 10, I'll take the times out, 10p cubed times 1 minus p squared equals 5p to the power of 4 times 1 minus p. Now what I'm going to do at this point is I'm going to divide through by p cubed, so that's going to give me a p over there. So if I divide through by p cubed, I divide that by p cubed, then that is going to cancel out. This is going to leave me with a p. Here I'm going to divide through by 1 minus p, divide through by 1 minus p, so that is going to cancel out on that one there, and this one is going to leave me with a 1 minus p there. So what I'm left with, so I'm not quite got enough space over here, so I'm going to go over here, is 10. The p cubed cancels out. I'm left with 1 minus p equals to 5. P to the power of 4 divided by p cubed is p, and the 1 minus p is cancelled out. So I've now got something lovely and simple that I can solve. And you could use algebra to solve that. I'm sure absolutely no problem at all. I'm just going to use solver on this. Now, just because little errors can always creep in on this sort of stuff, and we've paid a lot of money for these gadgets, so why not use them? So I'm going to go into the equation, I'm going to go into solver, and I'm going to type in this equation here. Don't forget, when you're using solver, you can always use it when you're doing a linear equation. Yeah? Linear equations are when we can use solver. I have to use my variable is my x. I've got my equals button is down here, 5x, and there I've got my equation. So I'm going to press exit. Now one of the big mistakes here is that is not the answer. You must press solve when you use solver. So you can go straight from that to I have my probability of 0.6 recurring is what that is. Now that seems fine. That looks like a good answer. It's 2/3, I think, isn't it? One thing which you should always be thinking about on questions like this is how can I check it? How can I check my answers? Now, what I would be doing here is putting this into this binomial and just making sure that those two BPDs are equal. So let's just do that. So I'm going on to stats, going to distribution, binomial, BPD, and I'm going to type in on here a number of trials of 5. I'm going to type in my probability of 0.6666666, and I'm going to check what the probability for it being equal to 3 is, and I get 0.3292. Just remember that number. I'm going to type in 4, and I get exactly the same number. So that seems to be the right answer. So that's good. That's a nice little check. Okay, so pause the video at this point. You try the now you try, and when you've done it, restart the video and I'll do the example. Okay, pause now. Okay, so here's your solution for the second part. So a very similar type of question. So I'm given the binomial without the probability, and I'm told that two probability statements are equal. So let's work out the probability of x being equal to 10. So I'm going to use my formula. N is 21. In this case, R is 10. So this one is going to be 21 C10 times p, which I don't know, to the power of r, which is 10, times 1 minus p, the probability of it not happening, multiplied by n minus r, which is the difference between that and that. So that is 11. Let's just do the next one. Probability of x equal to 9. So that is 21c 9 times p to the power of 9 times 1 minus p to the power of 21 minus 9, which is 12. So let's do some calculations on there. I think I'll go scientific for the NCR this time, just to mix it up a bit. So 21 C 10. So I've got 3, 5, 2, 7, 1, 6, p to the power of 10 times 1 minus p to the power of 11. 21 C 9. I've got 293,930 p to the power of 9 times 1 minus p to the power of 12. Okay, I know those two things are equal, so I'm going to write out all of that. Okay, I'm going to divide through by p to the power of 9 to cancel this out, which will become p. I'm going to divide through by 1 minus p to the power of 11, so the smallest one. So we can see that this is going to cancel and this is going to cancel. So I end up with 3, 5, 2, 7, 1, 6, p. Those disappear or cancel down to 1, so we'll multiply by 1, equals 293,930. Cancel 1 minus p. I'm going to go solver. Three, 5, 2, 7, 1, 6. Variable button equals 293,930 bracket 1 minus variable. Remembering to press solve, and I get p equals 0.4545. That's my answer. I really want to check it because I want to know that this is correct. I'm going to go to my distribution, my binomial, and BPD. Okay, so I'm going to set my number of trials to be 21 in this case. I'm going to set my probability to what I've worked out as the answer. I could go to more decimal places if I needed to, but that should be good enough for this check. And I want to check what the probability of being 10 is. There we go, 0.1688. Remember that number. Go back, go to 9, and 0.1688. So that feels like that is a correct answer. Well, that's confirmed that it's a correct answer. Okay, hope that was helpful.